Hi everyone, welcome back. Today we are solving find largest area of square inside two rectangles. So in this problem, there will be n rectangles in a 2D plane with edges parallel to the x and y axis. And we will be given two arrays which are called bottom left and top right. And bottom left will signify the bottom left coordinates of the squares and top right will signify the top right coordinates of the squares. And we want to find the maximum area of a square that can fit inside the intersecting region of at least two rectangles. And if no square exists between two intersecting regions, then we can return 0. So if you look at this example, the largest square has an area of 1. It can exist here or here or here. So we return 1. In this example, the largest rectangle will have an area of 4. It can exist right here or right here or right here or right here. So we return 4. In this example, the largest area is 1. It can exist right here or right here or right here. So we return 1. And in this example, no regions intersect, so we return 0. So now that we have seen some examples, let's get to how we can solve this problem. So there will basically be three types of scenarios between two rectangles. The first one will be no overlap, the second one will be partial overlap, and the third one will be a full overlap, meaning one rectangle is in another rectangle. But either way, to calculate the width and height that is overlapped, we can use this formula, the smaller top right x coordinate subtracted by the larger bottom left x coordinate. So if we look right here, the smaller top right x coordinate would be right here because this one is smaller than this one, and the larger bottom left x coordinate would be right here. So as you can see, if this subtract by this would be the width, and same for the height. The smaller top right y coordinate is here and the larger bottom left y coordinate is here. So if we subtract this by this will be the height, and it would be the same for partial overlap. The smaller top right would be here because this one is smaller than this one, and the larger bottom left would be here because this is larger than this. And if we subtract this way, we'll find the width. Subtract the y coordinates, we will find the height. Now if there's no overlap, we realize that the width and the height will both be negative. So if you could look right here, the smaller top right is this and the larger bottom left is this. If we subtract this to this, it will be negative. So if any of these are negative, then we will just return area as 0. Otherwise, we will do the minimum between height and width and multiply that by itself or square it, then that will be the area. So what we can do is we can pair the input arrays bottom left and top right together into one list. And for Python, you can use the zip function to do that. And we will iterate through all the combinations of the pair that we did in step 1. And we will use the formula earlier to find the longest side that can fit inside the intersecting regions of the rectangles that we are iterating through. And we will keep track of which side is the longest, and then we will return the longest side times the longest side because that would be the area. So let's go over this example real quick. So first, we will take bottom left and the top right array, and then we will pair them. So now the bottom left coordinate is paired with the top right coordinate of that rectangle. So first, we'll intersect these two rectangles. For the width, the smaller of the top right x coordinate is 3. The larger of the bottom left x coordinate is 2. So 3 minus 2 is 1. So that will be our width. And the same for height. The smaller for the top right is 3. And the larger for the bottom left is 2. So 3 minus 2 is 1. And now between width and height is the same. So the minimum of the two would be 1. So now we can update our largest side to 1. Now we look at the next pair. We'll compare this rectangle with this rectangle. So the width will be 0 because the larger between the bottom left would be 3 and the smaller between the top right would also be 3. 3 minus 3 is 0. Now we look at the height. The height is 2 because the smaller for the top right is 3 and the larger bottom left would be 1 and the height would be 2. As you can see right here, 3 and 1 is 2. This has a distance of 2. Now the minimum between these would be 0, so the side would be 0. So 1 will still be our maximum side. Now we can look at the last pair. 4 is the smaller of the top right. 3 is the larger of the bottom left. So if we do 4 minus 3, the width would be 1. Now if we do height, this is the larger of the bottom left, the smaller of the top right. The 4 4 minus 2 is 2, so the height is 2, but 1 is smaller than 2, so this side would still be 1. So our largest side that we have found is 1. So now we will multiply 1 by 1, and our maximum area that we can find is 1. And as you can see, we can form an area 1 here, and 1 here. So we can return 1 as our result. And the time complexity would be O of n squared, where n is the number of inputs in bottom left or top right, because we're not just looking through each specific point, but at each specific point we look at, we will have to pair it with all the other points, so that's why it's n squared. And the space complexity would be O of n squared as well, because this can take up to n squared space. So now let's get to the coding part. So first we will set side to 0, then we will zip bottom left and top right, and we will call it ARR for array. Now we will loop through the combinations of the array that we just created. So we will do XBL, 1 for the X coordinate of bottom left, YBL for the Y coordinate of bottom left, and XTR for the X coordinate of top right, YTR for the Y coordinate of top right, and 1 would be the first rectangle. Now we will do XBL2, YBL2, and XTR2 and YTR2 for the other rectangle. So I'll just copy and paste and swap everything to 2, and it will be for that in combinations of ARR, comma 2. Now the width would be the minimum of the top right subtract by the maximum of the bottom left between those two rectangles. So we will take the x coordinates of all these two rectangles and subtract. And the same for the height, except it'll be the y coordinates. So the minimum of YTR1 and YTR2 subtract to the maximum of YBL1 and YBL2. So Y bottom left and Y bottom left 2. Now the side would be the maximum of the side that we currently have, or the minimum of width and height that we just calculated. And then finally we can return side multiplied by side. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comments section, and I hope to see you all again soon.